I'm Anil Kumar. Welcome to this video on partial fractions decomposition. I've taken 4 examples which will give you the variety which you should understand while writing the partial fractions for a rational function. The question here is, express as sum of partial fractions a, x plus 1 divided by x minus 2 times x minus 3, b, x plus 2 divided by x times x minus 1 whole square. We have x minus 1 over x cubed minus 1, and here we have 6x square minus 11x minus 1 divided by x minus 3 times 2x minus 1. Now all these rational functions can be written in the form of sum of partial fractions. For example, you can write x plus 1 over x minus 2 times x minus 3 as equal to a over x minus 2 plus b over x minus 3, right? Now in case the factors in the denominator are not repeated, that is how you do it. Now in part B, I've taken a case where the factors are being repeated, right? So in that case, we will have to have 3 parts in this case. So we could write this as, let me write here in a different ink, x plus 2 over x times x minus 1 whole square will be written as a over x plus b over x minus 1 plus c over x minus 1 whole square, correct? So that is how you are going to decompose it. Is that clear to you, right? Now sometimes what happens is we have something here where we might land up with a quadratic expression in the denominator. So let me rewrite this. It could be written as x minus 1 over a cube minus b cube gives you x minus 1. Well, let me change this question. Okay, because then x minus 1 will cancel, correct? So let me make it plus 1 here. Okay, so we just changed the question. I didn't want to cancel. Okay, so x minus 1 times x square plus ax, which is plus x plus 1, correct? Now this part, x square plus x plus 1, cannot be factored, right? So how will you write this as a partial fraction? Well, the technique is like this. So I changed this question. So we have here now x plus 1 over x minus 1 times x square plus x plus 1, right? Now we will write this as a over x minus 1, right? That's clear. Plus what? Now since we have denominator which is of order 2, we should have a linear function on the top, right? So we'll write this as plus bx plus c over all this, which is x squared plus x plus 1. Is that clear to you, right? Perfect. The last one here is slightly different from the previous ones. What you notice is that the degree of numerator and that of denominator is same. That means you could actually write this as what? We have 6x squared minus 11x minus 1 over, we have x minus 3 times 2x minus 1. So here we'll get a constant factor a plus b over x minus 3 plus c over 2x minus 1. Perfect. So do you see that? So these 4 examples are very important to review all the concepts, and they will give you the required skills to move forward. And we use this technique to a large extent in calculus, right? So we will use this technique in calculus. So we use partial fractions in many examples. One of them is to find, even we use in binomial expansions. We'll learn that, right? And we will also see how we can use them in calculus. To differentiate functions and to integrate functions, we use this technique of partial fractions, so it is extremely important. Now let's just see how exactly to do them. As we discussed, we could actually write this particular rational function as a over x minus 2, right, plus b over x minus 3. Now the idea is to find a and b. So how do we do that? Now for this also we have two different methods. So we'll discuss both the methods and then we'll follow one method for the rest of the examples. So we'll have two methods, method 1 and we'll discuss method 2. Okay. Now in one of the methods what we do is we begin with the right hand side, which is a over x minus 2 plus b over x minus 3. So let me rewrite this as a over x minus 2 plus b over x minus 3. We can take a common denominator, so we're going our way backwards, right? So we get here x minus 2 times x minus 3, cross multiply, we get a times x minus 3 plus b times x minus 2, right? Now we can expand the new on the top. So denominators of these two are exactly same, right? So if when you expand that, what we get here is that we get ax minus 3a plus bx minus 2b, right, over all this. So you can now see that the x values, when you can factor, you get a plus b in this case. You could write this as a plus b times x. As far as the constants are concerned, we have, in this case, we have minus 3a and 2b. So we could write this as, well, minus 3a plus 2b, right? I took minus outside. So we get this as x minus 2 times x minus 3. Now if you compare the coefficients, see here, x plus 1 should be the numerator part, correct? So if you compare the coefficients with this equation, which basically for us is what? We have x plus 1 over x minus 2 times x minus 3, correct? So that is what is given to us. So when you compare, the coefficient of x is a plus b, right? So what we get here is that a plus b should be equal to 1, since coefficient of x is 1, and also 3a plus 2b should be equal to, this is with negative sign, so I'll make it negative 1. Is that clear to you? So we get two equations, and from these two equations you can solve for a and b, right? So you can solve for a and b. So that is one method of doing it, correct? Okay. The other method is something like this. We'll do it on the right side. And then we'll calculate the answer, right? So if I cross multiply, so I have all this, right? So we could actually write this as x plus 1 is equal to what? So if I multiply, so let's again move from here, right? So if I multiply all of them by this factor x minus 2 times x minus 3, in that case we get this as a times x minus 3 plus b times x minus 2. Clear? That is this numerator. Is it clear? This numerator should be same as x plus 1. That is what we came to, right? Now at this stage you will notice that if I substitute x equals to 3, then what happens? If I substitute x equals to 3, I get here 3 plus 1 equals to, that part is 0, right? So a times 0 plus, if I substitute 3 here, I get 3 minus 2, which is 1. So I get b, right? So clearly from here I get a value of b, which is equal to 4. Is that clear? Now if I substitute x equals to 2, then what happens? Substituting 2, we get 2 plus 1 equals to, now this term will be 2 minus 3, which is minus 1, and that term becomes 0, right? So then we get a as equal to minus 3. Is that clear? So this is a shortcut method, but both are valid methods. Now once we get b and a value, you can actually check that it really works. You could have solved this also perfect. So to do this, we could say from here that a equals to 1 minus b, for example, and which confirms, and then you can substitute the value of a in the second equation, which is 1 minus b. So 3 times 1 minus b plus 2b equals to minus 1. So you get equation in b, which you can solve. So what we get here is 3 minus 3b plus 2b equals to minus 1. And solving this, we get b equals to 4. Correct? So we do get the same answer. However, the second method is very fast, right? So we prefer this method most of the time. So I hope the steps are absolutely clear. Perfect. Now let's move on and take up the next example. I would actually like you to pause the video, solve this question. We need to partial factor x plus 2 over x minus 1 whole square. So we could always write this as a over x plus b over x minus 1. Now, since this is repeated, right? So we'll say plus c over x minus 1 whole square. Clear? So that is how we are going to do it. So you can adopt any method to find the solution of this one and then check with my solution. So now let's apply our second method to find the solution. We can write this as x plus 2 equals to a times what? So we already have x, so it will be x minus 1 whole square plus b times what? B times x minus 1, correct? Plus c times x, or we can write cx. Now to solve this, we have to look for what substitutions can help us get the values for the constants a, b, and c. So these two could become 0 if I take x equals to 0. So if I substitute x equals to 0, I get 2 equals to a, and that is minus 1 square. So I straight away get the value of a, correct? These two terms are 0, right? So we get one value. Now how do I find the other one? If I substitute x equals to 1, right? If I substitute x equals to 1, in that case this will be 0 and that will be 0, right? So substituting 1, I get 1 plus 2 equals to what? This is 0, this is 0, I get c. So I get the value of c. So 1 plus 2 is 3, right? So we get c equals to 3. So with x equals to 0, I get a equals to 2, and with x equals to 1, I get c equals to 3. Correct? Now we have the value for a and c. Let us substitute those values. So our equation now is x plus 2 equals to a is 2 for us, right? So we get 2 times x minus 1 whole square, and the value for b is not known but c is known. So we can write this as plus b times, you can multiply this, we get x square minus x plus c is 3, so we get 3x. So that becomes our equation. Now only one variable is there. We could substitute any value of x, or we should not be doing 0 and 1. So let us put x equals to 2 now. Substituting 2, we get here 2 plus 2, which is 4, and here we get 2 times 2 minus 1 is 1, right? So that is 1, plus b, 2 square is 4, 4 minus 2 here, and plus 3 times 2, correct? So that gives you 4 equals to 2, and here 4 minus 2 is 2, plus 2b, 3 times 2 is 6, we get plus 6. Now 6 plus 2 is 8, so we get 4 minus 8 equals to 2 times b, so which is minus 4 divided by 2 is the value of b. So that gives you the value of b as equal to minus 2. Okay? So we get b as minus 2. Perfect. So that is how we can actually solve for these values. So you see how substituting some values of x can get us very fast result. So we could write our answer as 2 over, so this expression now becomes x plus 2 over x times x minus 1 whole square should be equal to 2 over x plus b is minus 2, so let's make it minus 2 over x minus 1 plus c is 3, so 3 over x minus 1 whole square. Is that clear to you? So that is how we will be solving it. Now let's take the next example. Now we need to decompose into partial fractions x minus 1 over x cubed minus 1. Now basically x minus 1 over x cubed minus 1, we changed this question, right? So we'll make it x plus 1. The idea was we don't want to cancel. We want to work with some interesting numbers. So we have here x minus 1 times, now this could be factored, it is x squared plus x plus 1, right? Okay. Now how do you partial fraction this one? So of course one we have 1 over x minus 1, right? The other one will be a linear function, so we'll have bx plus c in the numerator for the quadratic term, which is x squared plus x plus 1. Is that clear to you? All right, so that is how we are going to get our expression. Now, in this particular case, we'll again cross multiply, and we can write that x plus 1 is equal to a times this x squared plus x plus 1 plus bx plus c times x minus 1. So one substitution is simple. We could say x equals to 1, and this term will cancel, so we get the value of a. So as soon as I do that, I get 2 equals to a times 1 plus 1 plus 1, and this is 0, right? So we get the value of a as 2 over 3. Clear? Now we need to find bx plus c. We know what a is. A is 2 over 3. So we have our expression, which is x plus 1 equals to 2 over 3 x squared plus x plus 1. And here we have bx plus c times x minus 1. Now we could substitute x equals to 0. We have to do two substitutions, correct? But if I substitute x equals to 0, the b term will get cancelled, right? So if I now do x equals to 0, what do I get? So let me write it here. We'll do x equals to 0 and then write down whatever we get here. So for x equals to 0, I get here 1 equals 2. So this becomes 2 over 3. The first term, 0, 0 times 1 over this, right? This is 0, right? So we get c with a negative sign. X is 0, we get minus c. Minus c. So that gives you the value of c as equal to 2 over 3 minus 1. So that is 2 minus 3, which is minus 1 over 3. So we get the value of c, correct? So 0 gives us the value of c, and now we need to find the value of b, right? Okay, so we could substitute x equals to minus 1, for example. Just take some value, right, to get the value of b, because this is an identity and it is valid for all values, correct? Okay, so when I substitute minus 1 in this equation, we know c is minus 1 over 3 for us. Okay, so and we know that c is equals to minus 1 over 3, correct? So with minus 1, left side becomes 0. We get 0 equals to 2 over 3 times minus 1 gives me 1, minus 1 plus 1, right? Plus we have here b times minus 1, let me write minus 1 now, plus c, which is minus 1 over 3, right? And minus 1 gives me minus 2 here. So that becomes our equation. Perfect? Okay. So let's try to solve this one. So what we have here is that, okay, so we have to put a bracket in this term because this is kind of a bracket like this. Okay. Right. So we have 0 equals 2. So it's minus, this is only 2 over 3 for us, right? Minus b times minus 2 makes it plus 2b, right? This times this is plus 2b, right? And here when we multiply, minus and minus becomes positive 2 over 3. Okay, positive 2 over 3. So now we can get the value of b. So 2 over 3 and 2 over 3 is 4 over 3. So that gives you minus 4 over 3 is equal to 2b. And that gives you the value of b as equal to minus dividing by 2 as minus 2 over 3. Clear? So we get the value of b as minus 2 over 3. So now we have all the three values. We can write down our expression. Let me just write the answer on this side. So what we have here is we changed the question, became very interesting. X cubed minus 1. This could be written as a. The value of a which we found was 2 over 3. Correct. Value of c is equals to minus 1 over 3. And for b is minus 2 over 3. So what we get here is x plus 1 over x cubed minus 1 is equal to a, which is 2 over 3. So we can write this as 2 over 3x minus 1. And then we have plus b is minus 2 over 3. So we'll write minus 2 over 3x. And c is minus 1 over 3. Minus 1 over 3 over, we have here x squared plus x plus 1. Okay? This could be simplified and we could write this as 2 over 3x minus 1. Both are negative. Let me write negative here. And 1 over 3 comes down. So we get 2x plus 1 over 3 times x squared plus x plus 1. Does make sense to you? So that is how we could do the partial fractions for the given rational function. I hope that makes sense. Correct? Now let's take the last example. Now in this case we have 6x squared minus 11x minus 1 divided by x minus 3 times 2x minus 1. Now as you see, their degrees are same, numerator, denominator. So we do expect a constant here. So we'll have a horizontal asymptote here, right? So, okay. So we could write this as a plus b over, there is no repetition here, x minus 3 plus c over 2x minus 1. So now we could write this as 6x squared minus 11x minus 1 equals to a times both these factors, x minus 3 times 2x minus 1, correct, plus b times one of these factors, which is 2x minus 1, plus c times x minus 3. Clear? Now what substitution should we do? So we can solve these values for different substitutions. If I substitute x equals to 3, then c is 0, right? Correct? And a is 0. So we'll begin with x equals to 3. So if I do x equals to 3, in that case we get here 6 times 3 square minus 11 times 3 minus 1 equals 2. So c and a are 0, we get b times 2 times 3 minus 1, correct? So let's use calculator to find this value. Right? It's not very difficult, but still. So we get 6 times 9 minus 33 minus 1, which is 20. So we get 20 here equals to 6 minus 1 is 5, so we get 5b. So from here we get 20 divided by 5 as the value of b. So 4 is the value for b. Is that clear? So we get one value. Now, so that is when we substituted 3. Now we can substitute half, right? So let me do x equals to half. So if I do x equals to half, what do I get? So here we get 6 times half square minus 11 half minus 1 equals 2. Now that becomes 0, a and b, both coefficients are 0. So we get c times half minus 3, correct? Let's again use calculator. So we have 6 divided by 4, 6 divided by 4 minus 11 divided by 2 minus 1, and that is minus 5. So we have minus 5 here, and this is 0.5 minus 3, right? So which is minus 5 by 2. So this is minus 5 by 2c. So from here we get minus cancels, so we get 5 times 2 over 5 as the value of c. So that gives you c is equal to 2, right? So c equals to 2. Now we have the value for c, and we also have the value for b. We need to find a. So what we can do here is we can substitute all this along with let's say x equals to 0, right? So we could do that. So what we will do now is we'll substitute x equals to 0. We know b equals to 4, and we know c equals to 2. So let's do this substitution and write here at the bottom. We have space. We'll use this space now. Okay. So as soon as I substitute 0 on the left side, we get minus 1. So we get minus 1 equals to a times, we get minus 3 here, and minus 1. Okay. And plus b is for us 4. So I'm writing 4 here times minus 1, and c is 2. So plus 2 times minus 3. Is that clear? So we substitute 0, 4, and 2 for x, b, and c. So that gives you minus 1 equals 2. That becomes 3a. Here we have minus 4, and here we have minus 6. So that means 10, and when you take it on this side, it becomes positive. So we get here, these two terms are negative 10. Let me write minus 1 equals to 3a negative 10. Okay. Let's take it here. So basically 3 times a is equals to 10 minus 1. So 3a equals to 9, and a equals to 9 divided by 3, which is 3. Clear? So we get value of a as equals to 3. Okay. So substituting all these values, we should get our answer. So a is 3 for us. So we get 3, b is 4. So plus 4 over x minus 3, and c is 2. So we get plus 2 over 2x minus 1. Is that clear? So I hope that makes sense. So in this video, we learned different techniques to do partial fractions of rational functions. We began with these 4 examples. They are of different kinds, and they help you to understand how such problems can be solved. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching, and all the best.